Hello world, this is Joe Strout, and today I'm going to show you how to get started with Mini Micro, especially targeting this video for people that may be already developers in other environments. Maybe you're working on a game jam, maybe you just want to learn a fun new environment, and with this video we'll get you up and running with Mini Micro very quickly so you can start writing some cool games and demos of your own. So you would start by going to miniscript.org/minimicro, and that takes you to this page. And I'll do a quick tour of the Mini Micro website. Notice there's 5 tabs across the top. You start on the About page, which has some specs for the Mini Micro virtual machine, some promotional text, and then at the bottom, a really cool trailer, which I definitely recommend you watch because it's a lot of fun. Then is the download page, and here you can download Mini Micro for Mac, Windows, or Linux. We'll come back to that in a minute. There's some version info. You can get to the release notes, which as a new user you probably don't care about, but it's nice to know that they're there. And then under more free stuff is some things that you should be aware of. This is the WebGL template that you'll use when you want to publish your game to the web, like on itch.io, for example. The Mini Micro cheat sheet, which is certainly worth getting. I'm going to go ahead and click that now, and it's downloading. Nope, it's opening in Firefox. Well, let's download it. Put it in my daily purge folder. Oh, it did download it. Well, that's nice. This is a 4-page quick reference for the Mini Micro API. Includes a link to the wiki and some example code that you can type in and try. And then the last page is a quick reference for the Miniscript language itself. So if you haven't used Miniscript before, here in one page is pretty much everything that you need to know about how to code in Miniscript. So that was the cheat sheet. And then under downloadable content, there are just some more polished, complete games that you can download and open up in Mini Micro later, but you probably won't need to do that on your first day either. Now tab, there's a web build of Mini Micro that you can use right within the browser. We don't need that today because we're going to download it for the desktop. The Learn tab is really important. This has all the, well, certainly not all, but a lot of good learning resources for learning Miniscript or Mini Micro. It's another link to the cheat sheet because it's that important. The quick reference is just the 1-page overview of the language. You get that included in the cheat sheet. And then the Miniscript manual is a more in-depth language guide if you need that. The wiki is really important. Let's open this in a new tab. The wiki has a bunch of really useful how-to articles, and then of course there's reference materials on all the different APIs that you can use in Miniscript and Mini Micro, as well as the language itself. And then if you go to Miniscript on Rosetta Code, you'll find lots of short sample programs in Miniscript. The last tab here is Games and Apps. This is certainly not exhaustive, but it's a selection of games and programs for Mini Micro, and a lot of them you can play right online. So if it says something like Play Now, it's going to open in the Play Now tab on this website. If it says, link to itch.io, then it's going to go to the site on itch.io, and you can run it right there. And boy, the way I've made my window here doesn't quite fit. There we go. I should point out that the surrounding frame that looks sort of like a old school computer monitor, you can remove that if you want. I like to leave it on, but you don't have to. You can also change it to a different color or appearance by specifying a custom image. That's all kind of advanced stuff, but just know that if you want to package your game so that it doesn't look like it's Mini Micro, you can do that. So this is running and I'm playing with the keyboard here. This is a little game jam game from, I don't know, about a year ago, I think. And I'm dead. Let's go back. Okay, so that's a quick overview of what you can find at the Mini Micro website. Let's go back to the download tab. And since I'm running on a Mac, I'll click Mac OS. where I want to save it, put it in my daily purge folder, and now let's switch to that. Okay, so wow, those are big icons. This is what I just downloaded, minimicromech.zip. I'm gonna open that with the archive utility to unpack it completely. Obviously, how you do that on Windows and Linux is a little bit different, but in any case, you want to be sure to fully unpack that. Don't try to run minimicro from within the zip file. When you've done that, you get the minimicro application. You can double click that to launch it. And if it's the first time, you get the standard OS security warning. You say, yes, I really do want to launch it. Here we go. So now we're in minimicro. And let me just actually move this out of the way. And let's just look around for a moment at what we can do in minimicro. It'll always show this welcome screen on boot, and then it ends with enter help for help. This bit here is a random tip, it varies, but it'll always show you the welcome, the version, and enter help for help. If you do that, it'll give you some introductory stuff, and it'll say for more help, enter help topics. Notice that you have to put that in quotes. And then here's other topics. So let's say I'm curious about the graphics in minimicro. I can say help graphics. And it'll give you just brief overviews of some of the graphics related commands in this case. The help is meant to just sort of get you up and running quickly, but for a more complete reference, definitely use the minimicro cheat sheet, which is here. This is what we were looking at before on the web, which has information on pixel display, text display, tile display, sprites, and so on. Or the wiki, which is also a great source. Includes how-tos and sample code. But there's that. Notice demos. Let's do help demos, because minimicro has a lot of demos built in. And here it tells you exactly how to get to them. So let's try that. We'll do cd/sys/demo. Notice that when you use the cd command, you do have to put quotes in around the argument. And the reason for that is that we are actually at the minimicro prompt here. I could do print hello world, and it does it. I can define functions. I can do anything right here on the command line. And even cd is a minimicro function. But like most programming languages, when you have a string literal, you have to put quotation marks around it. So that's why we say cd quotes sysdemo to go to the sysdemo directory. Then to list the files in that directory, we can do dir. And here are all the demos in the sysdemo directory. And then we could run one, for example, turtle demo. And it does a little turtle graphics demonstration. When you use the run command, it loads it. When you use the run command with a file path, it loads that file onto memory and then runs it. There's also a load command that just loads it. In either case, we now have a program in memory. And if we use the edit command, we're editing that program. So right now, the editor is showing us sysdemo turtledemo.ms. And this is the source code for the demo that we just saw. I can go down to here's the main loop. Right here, loop and draw. And the reason that it was drawing slow enough to see what was going on was because of this wait command. But we could comment that out, and then exit, and run again. And wow, okay, that went so fast we couldn't see it. Run. There you go. Another way to run from the code editor is to just click the close and run button, or press F5. Those all do the same thing. Let's see what else we've got here. Oh yeah, notice that minimicro has a multi-layer display system. So right now it's configured as is the default with a text display on top of a pixel display. And that's why we're seeing this directory listing on top of the output from that turtle demo. To make it easier to read, I'll just do clear, and then there. So another good demo is maybe Asteroids. Oh, here's an interesting point. Because I modified that turtle demo, it's asking me whether I want to save or reset before loading the file. Otherwise, my changes would be lost, perhaps unintentionally. In this case, I don't care to save those changes, so I'm just going to say reset, and then run Asteroids. And notice I can just up arrow to get to previous commands, up and down arrow to step through history, just like in a typical shell. Okay, so here's the Asteroids demo. I actually really love this game. And boom. Nice. Alright, enough of that. You don't want to watch me play Asteroids. To stop the game, I hit Control-C, and that'll break out of pretty much any program. It is possible to disable that function as well, though. So don't worry, if you're publishing a game, you don't want people to break out of it with Control-C, you can turn that feature off. Let's clear the screen. And I think that's probably enough, but I encourage you, when you're doing this on your own machine, to really look through these demos, run them all, look at the source code. Oh, there's a fun way to get to some of them through the demos command, which actually runs sysdemo demos. This lists a bunch of demos, not all of them, but a subset, and it's kind of fun in that it shows you the source code before you run it. So often there'll be comments at the top that tells you something about it, and then you see something you like, you just hit return, and it types all this load and run command for you. And then when you exit, in this case I exit this demo by pressing the escape key, it goes back to the demo's program. So anyway, explore the demos. That's my point. Lots of good stuff to do. It's fun, and you'll get a good idea of what Minimicro can do and what the code looks like. But now let's go on to the next step. These are all the files that are built in. They're on the sys disk. In fact, if we use the find file command, it'll show us the disk structure. So at the root level, there's sys, user, and user2. The sys disk is built in, and it's read only. So you can't actually change anything on this disk. Like that turtle demo that I'd modified, if I wanted to save it, it would have forced me to save it somewhere else, because you can't overwrite what's on the sys disk. But what's on the user and user2 disk, you certainly can. And let's see, I've got disks mounted here, and user2 because I've run Minimicro before. If you're running it for the very first time, you'll have a default storage place where the user disk is mounted, and you'll have nothing in user2. But let's talk about how you can mount a directory of files to work on. Let's see. Let's talk about how files are stored in Minimicro. There's two ways that you can get your own files and store your own data in Minimicro. One is a disk file, and I can create a new disk file by clicking on either of these disk slots. This is user and this is user2, and saying new disk file. And it'll ask me where do I want to save it and what I want to call it, and it'll be called something.minidisk. And a minidisk file is really just a zip file, but with a minidisk extension. And by default, Minimicro will create one of these for you on your first launch, and that's where your user disk will be stored. But if you're a developer, it's usually more convenient while you're working on your project to mount a folder of files in the host OS. So to do that, you click on a slot and you say mount folder. And then it brings up the standard disk browser for your system, and you can say, select a file or a folder that you want to store your files in. I'll put one here in daily purge called Minimicro test. And then I say open, and now when I do dir, oops, let's do cd to go back to the user directory. And dir shows me the contents of that directory, which is currently empty. Now if I were to go to that directory in the Finder, mini micro test, and let's put something in here. I'm going to make a new window and find, let's say, I don't know, an image. We'll go to we'll take this image and we'll copy it into that folder. So there it is. And now if we do dir, you can see there's the file icon. I can use the view command to view it. So this is how what you see in Mini Micro relates to what you have on the host OS. Similarly, if I were to create a program by doing reset and then edit, do like print hello world, and save this as hello.ms, then when I look at it in the Finder, there's hello.ms right there. So you can see that this folder in my host operating system is just mapped now to the user directory in Mini Micro. And for most users, that's the way that you'll operate. Now, there is a bug on certain versions of Linux where the native file dialogues do not work. But don't worry if that affects you, there's another way to do it. In Linux, you often launch programs from the command line, and when you launch a program, when you launch Mini Micro from the command line, you can specify the user and user2 directories that you want to use. So let me go to the daily purge folder. There's Mini Micro, and here's the Mini Micro test folder that I want to mount as my user directory. So I could just do, let's see, on Mac I think you actually have to, can I launch it just this way? I don't actually launch applications from the command line that often on Mac, but I think I can do this, and then -user Mini Micro test. Nope, you can't launch apps that way. Okay, you have to go down inside it. Hang on, I'll get there. Right, contents. Mini Micro, that app, contents, macOS, Mini Micro. Okay, -user Mini Micro test. And it launched over here, but there you go. And it's got the correct folder mounted. And you generally only need to do that when you're changing what folder you want to mount, because it does remember in the application preferences which folders or disk files were mounted before. So by one way or another, we now have Mini Micro mounted, we've got Mini Micro running, and we've got a user directory mounted where we can put our files. So if you get that far, you are all set. Now it's just about learning how to use Miniscript and Mini Micro to create a game. So let's start by creating a sprite. I'm going to do this on the command line. So let's do sp equals new sprite, and then give it an image. syspix wampus.png. This is a path to one of the built-in files on the system disk. And to verify that we got that right, I could do view sp.image. Yep, there it is. Okay, and then display4, which is the sprite display by default, .sprites.push sp. And there's our wampus peeking out from the corner of the screen. Now, we can set various properties on that sprite, like its X and Y position. We could set the scale. We can set the rotation. We could even do a little loop for I in range 0 to 360 in steps of, I don't know, 3. SP.rotation equals I and 4. Oh, we should probably put in a yield or it would be too fast. And 4. There we go. So that's how you make sprites from one of the built-in functions. What if you want to make a sprite from some custom image of your own, which you certainly will if you're creating your own game, right? In that case, the first step is to get your image into the folder that you've mounted. I've already got this image here called pile icon. So, and no, I don't remember why it's called pile icon, but it is. Let's load and use that. So let's clear the screen again. Let's do sp equals new sprite, sp.image equals file.load image, pile icon, and then display for.sprites.push sp. There's my pile icon. Let's bring it out where we can see it. And there you go. So, what if you have multiple images in a sprite sheet and you need to just extract one section of that sprite sheet? And there are some of the built-in images in Minimicro that in the sysdisk that are like that. Let's use the find file command again to find one. Syspics. Here's one. Syspics enemies.png. And you can see in the little preview that it's got, looks like 4 rows of images and 8 columns. So if we were to load that, let's load it, just the image itself using file.load image. And I can copy and paste here, syspics enemies.png. And then let's view it to make sure that we got it. Yep, here we go. Let's grab, let's say this top left image. Now, coordinates in Minimicro are bottom up, just like in math. So X is how far you are to the right from the bottom left corner, and Y is how far you are up from the bottom left corner. And that applies to images as well. So when we're figuring out, here, let me shrink this down a little. Figuring out where we are in this image to get to this character in the corner, the X coordinate is going to be 0, and the Y coordinate is going to be, well, 3/4 of the way, 3/4 of the height of this image. And it tells us right here how big the image is when I do the view command. So 3/4 times 512 is 384. So what we could do is sp equals new sprite. Actually, we can just use that same sprite that we've already got on here. This sprite is still on the screen, so let's use it. sp.image equals img.getImage. And this needs x, a y, which is 384, and then the width and height, which 1/4 of 512 would be 128. And there you go. There's our image. Let's do text.clear. There's our sprite created from a portion of that image. And we can now move it around and make it do things. And of course, you also just saw that I changed the image on the fly. So I did it this way. If we did something like frame 0 equals this, and frame 1 is similar but starts at 256, then we can do image equals frame 1 and frame 0. And we're making the guy walk. So now you can see how to do animation as well. All right, that's a quick introduction to sprites. Let's move on to playing sounds. Start by clearing the screen. And let's use the file.load sound command. And again, I'm going to load sound from the sysdisk. Those are always convenient because they're always there. And then once you've loaded it, you can just do sound.play. And the sound plays. Incidentally, if you don't happen to know the path of the sound that you're trying to load, you can do this. This works for images and programs as well, of course. But in this case, I'll do file.load sound, find file. And it opens up the little file browser. We can go down to sounds, and we can find something like this. And then sound.play is another way to get to it. Now, I'm using sound.play with no arguments, but it does have some parameters. We could look on the wiki, or we can just do @sound.play. When you stick an @ sign before a function reference, it suppresses the usual invocation of the function. And if you do it on the command line, the result is it just prints out function plus the parameters, including the default values. So you can see that the sound play method takes a volume, which defaults to 1, a pan, which defaults to 0, and a speed, which defaults to 1. So let's just play around with these a little bit. Let's do sound.play 0.5 or 0.1. Gets quiet. Go back to a volume of 1, and gosh, I could play around with the pan, but I don't know if that's going to come through on YouTube. This would be all the way on the left speaker, and this would be all the way on the right speaker. Again, I don't know if YouTube preserves the stereo, but if you try it on your own machine, you should hear that. And then we can play with the speed. By default, speed of 1 is what it normally sounds like. If we double that, it's higher pitched and faster. If we cut it in half, it gets lower pitched and slower. So these are ways that you can play with a sound. Oh, I should point out that you can also do looping sounds, like if you have background music. So hang on, I'm going to take a moment to find some background music from one of my games. Do this where you can see, I guess. Let's see. How about this old Dr. Yon zombie experiment? I'm pretty sure that has some background music. Yeah, Dr. Yon music.ogg. I'm moving that into my project folder. And you can see it's 1.4 megabyte OGG Vorbis file. When it comes to larger sounds, I recommend OGG format. MP3 will work on the desktop, but it doesn't work on web, so you probably want to avoid that. Or for smaller sounds, use the WAV format. But if we do dir now, we can do music equals file.load sound. Let's just copy and paste. And then we can do music.looping, music.loop equals true, 1 or true, same thing in manuscript. And now we play. And it'll play. And you can actually adjust the volume, pan, and speed of a sound that's currently playing by using the adjustment. So music.adjust 0.1 makes it very quiet. Back to full volume. We can even adjust the speed. So that's kind of fun. To stop it, music.stop, or you can do sound.stop all, and that'll stop all sounds. Alright, I think that's enough on sound effects for now. Let's talk about how to write a program. So there's a couple ways to do this, and I've already shown the code editor sort of informally a couple of times, but let's really dig into it now. If I reset and then I say edit, we're in the code editor now. And this is a fairly full-featured code editor. It's got cut, copy, paste support. It's got find and replace. You can navigate to line or to any method that's in your program, and then it has some code wizards that'll help you do things like write a while loop. So let's make a program that does what? How about this? For I in range 1 to 10, or better yet, 10 to 1, print I plus some dots, wait a short time, quarter second, and 4, and then print last off. And then I click close and run, and it does its thing. You can use the save button, save it to disk, and if you haven't saved it before, it'll ask you where you want to save it. So we're going to call this liftoff. To specify .ms, it'll fill that in automatically, and here it is on disk. The other way, of course, is to use your favorite external code editor. You can use VS Code or whatever you like. On the Mac, I like to use BBEdit. So, gosh, as soon as I activate BBEdit, though, you can see I've got way too many BBEdit windows open. But let's open that folder, mini micro test, and then I'm going to see if I can hide everything else except that window, so it's not too cluttered. Nope. Nice BBEdit. All right. Well, anyway, here's my mini micro test folder and the scripts that I've created so far, as well as the images that I have in here. So I could edit my program this way. Let's say instead of waiting 0.25 seconds, I want to wait half a second. I can edit, save, go back to mini micro. Probably not a good idea to have the code open in both editors at once. And then I could do, actually the pattern I like to do is reset, load, lift off in this case, and then run. So reset clears out all of the state from the last run, which is usually a good idea. Otherwise you'll end up with, stale data from the last run, possibly causing problems with the new run. And then loads it into program and run. Or actually I could have just done reset, run, lift off. And maybe I'm now thinking, boy, I really should clear the screen at the start of this program, so I just go back to here, add a clear command, and then reset, run, lift off again. And once you've got something like this in the command history, I can just hit up arrow to do it again. So there's two ways to edit your programs. Either use the built-in editor or use your favorite external code editor. So with this, let's actually do a simple game. And I think I'm going to use the built-in code editor for this. We'll make a little UFO game. So let's reset. Oops. Reset. Edit. Let's start by preparing our displays by doing a clear and getting the sprite display, which by default is always display 4. Now let's load our UFO sprite and some other stuff. So prepare sprites and other resources. UFO equals new sprite. UFO.image file.load image. Oops. Sys pix UFO.png. Let's do the sprites that push UFO and then move it into the center of the screen at 480, 320. And let's save this as UFO and run it. Okay, so far so good. We have a UFO. Now let's see. I want to have like a fire button. And I always like to give the player alternate buttons that they can use because we don't know their situation. They may prefer to play with one hand or the other. So they may be using a gamepad or joystick. So I'm going to allow various fire buttons. which I'll define in a list. Spacebar, left shift, right shift. Notice I can continue a statement on the next line as long as I end with something like a comma or an operator. Joystick button 0, joystick button 1. And even though it's called joystick button, most people these days have gamepads. This works with gamepad buttons just as well. And then we'll define a function to report whether any of those are pressed. Call it fire pressed. There's function for button in fire buttons. If key.pressed button, then return true. And 4. Notice that the built-in editor automatically indents your code according to the structure, so you don't have to worry about that. Return false if none of the keys are pressed, and end function. Okay, let's try this much. So if I type fire pressed and I don't touch any of those buttons, it returns 0, which means false. By the way, true is 1 and false is 0 in Miniscript. Those are just magic numbers. But if I do fire pressed again, and this time I'm going to hold down the shift key, it reports 1. So that's great. That's working. Code a little, test a little, I always say. So now let's define what should happen to actually fire. So function to fire. And today, because this is meant to be a quick demo, I'm just going to have it play a sound. Fire equals function. And let's see. I have to load a sound. Fire sound equals fire dot load sound. You don't actually have to load a sound from a file. You can dynamically synthesize a sound on the fly, which is great, especially if you like sort of retro 8-bit sounds. But again, trying to be brief, so we'll just load this bland sound from the system disk. And then we just say fire sound dot play. Variables in Miniscript are local by default, but you can access global variables just by referencing them, as long as they're not shadowed by some local. You can just say fire sound dot play, and that should work. And actually, let's test that. Yep. See, this is why we test. Undefined identifier, fire unknown on line 11. Let's go to line 11. Oh yeah, I meant file.libsound. I bet some of you noticed that while I was typing it. Good job. All right, now if I say fire, cool. All right, so I think it's time for our main loop. Let's see. While true and while, and actually, handy tip, when you have something like a loop open, you can hit shift return and it will close it for you. So that's handy. I'm going to start my main loop with the yield statement, which suspends execution until the next frame. Frames come 60 times per second. So usually you want to have a yield statement in your loop to lock your animation to the frame rate. And then move the UFO. We'll move it, let the player move it around with the horizontal and vertical axes. So UFO x plus equals key.axis horizontal. And this key.axis horizontal is how you can support WASD or arrow keys or gamepads. So it's a great way to get directional inputs. We'll multiply that by 20 so it's a little bit faster. And then same thing for Y, but it's axis vertical. And then fire, then the fire button goes down. Okay, right, we want to keep track of when the user just presses the fire button. So let's introduce another variable, fire was pressed is false. And then we can find fire now pressed equals fire pressed, which is invoking our function above. If fire now pressed and not fire was pressed, then fire. And then we can keep track of fire was pressed by storing fire now test. Okay, that should do it. Let's try it. So I'm using the arrow keys here, or I can use WASD. That works too. And then when I press spacebar or shift key, or first couple of buttons on my gamepad, it makes the fire sound. This is so satisfying. Let's try this. Okay. So that is an introduction to Mini Micro. Let's see. The other thing you'll be wondering, I guess, is how to package your game for the web. So let me direct you to the instructions on that. I'm going to go back to the web browser, and from the Learn tab we can get to the wiki. I actually have the wiki open right here. And if you go to the how-to page, you'll find a variety of things, including how to package a Mini Micro game. And this is where you'll find the instructions on bundling up your game for desktops or for the web. And in this case, it's mostly about converting your folder files into a mini disk. So I'm going to show that part. I'm not going to show the whole process of uploading to itch and all that, but this is where most people get tripped up. If I wanted to turn this project, including my little UFO game and the resources it needs, into something I can upload to the web, I would start by selecting all those files and compressing them into a zip file. And then I would rename that zip file to user.minidisk. Now this is a mini disk file that you could actually mount right here in Mini Micro. In fact, let me show you that. Put it here in my daily purge folder, user.minidisk. I'm going to go to Mini Micro and say mount disk file, and up to daily purge, user.minidisk, and here we are. I'm still running that game. Hit Control-C to break out, CD to make sure I'm at the user level, and so now we're looking at the contents of that user.minidisk file right here. And if I had a special file called startup.ms, then when I reboot, it would actually run that startup program. In fact, you know what? I'll show that too. Why not? Let's reset, edit, and just say run UFO, and save this as startup.ms. Okay, so that's now on this user mini disk. Notice that it's not in my original project folder because I've already mounted my mini disk file at this point. So it's inside here, user.minidisk. And if I were to do reboot, that did not work. Why did that not work? I think I forgot to save my last changes to the UFO program. Oh, that's frustrating. Yeah, that's really annoying. Okay. If you do something like this, I guess first you kick yourself a little bit and then you fix it, which we can do real fast. But this time, just for variety, I'm going to fix it over here using BBEdit, an external editor. So here's UFO, and it so happens that I think I've got the code for this, which is in one of the how-tos on the wiki, that I could just copy over. I thought I could. Where did that file go? No? Here, let's find it. How to get started with Mini Micro. Here we go. Gosh, how much did I already have in there? That's the wrong folder. Almost nothing. Wow. Really should have saved my work. Oh, I should point out, this is kind of useful. there's an autosave checkbox here in the mini micro editor. If I had had this checked, I would have avoided this problem, because when you have this checked, every time you exit the editor, it automatically saves. That would have been a great idea, but I didn't, so now I'm paying the price. But let's just copy all of this. And this time, just for variety, I'm using BBEdit to paste it in. All right, and then save it. And remember, this is in the external files, so in Mini Micro, we're going to mount that folder again. Mini Micro tests. And you know what? Let's also create that startup file, which is a good idea. So, new text file, call it startup.ms. And all my startup file is going to do is run the main program of my game. Save that. All right. So, if I look, I see startup, I see UFO. Let's make sure the UFO works. Yep, it does. Okay. Now, having done that, we would come in here again. We would compress these things. Oops. I'm in the wrong place. Don't do that. Compress these things. And actually, I don't need the background music, so I'm going to leave that out. Compress. Call it user.minidisk. Let's move it back up to daily purge. It's asking me if I want to replace the old one. Yes, I do. Here it is. Okay. Now let's mount that user.minidisk. And this is just to test it, to make sure that your user.minidisk is correctly formatted. If you're confident in yourself, you don't have to do that. Oops. I think I said mount folder instead of mount disk file. Disk file. Here we go. Okay. Now we reboot. And our game is running. Okay. Wow. Thank you for joining me on that journey through forgetting to save my code and fixing it. So, to recap, you've learned how to download Mini Micro, how to mount a project folder, how to use either the built-in code editor or an external code editor to write your program. We looked at creating sprites and playing sounds and getting input from the user. So those are basically all the major functions that you need to start creating your own Mini Micro games. And then finally, we looked at how to compress all the files in your project into a user.minidisk file, which is the main step that you need to do in order to package your game for distribution on the web. And you can get details about that in the wiki. The other thing you should know is where to get help. And actually, if you go back to the Getting Started article and scroll down to the bottom, there's suggestions here on where to learn more. And the most important thing I would suggest is to join the community Discord server. And you do that just by going to miniscript.org, scrolling down to community, and right here is a link to the Discord server. Click that, you get an invitation, and you can join us on Discord, where you'll find lots of helpful and supportive people happy to help you as you learn Miniscript and Mini Micro. I hope to see you there.